Good evening, everybody. We will start in 3 minutes or so.
Good evening, everybody. Let us start. Yeah, Anusha, I hope my screen is visible to all. My voice is clear to all.
Yes, sir. Yes.
Okay, great. So today we will be doing this supervised learning. The theory is a bit small, but the practical sessions will be a bit long. So please be prepared for that. It may cross the time of 8:30, so I don't want to delay any further. Okay. And please be there because till the throughout the session, because this is a very important thing. The statistics was actually very simple, but supervised learning you need to learn major. It has very good applications. So please be there throughout. Please do not log off by 8:30. Okay. So, what is supervised? See, in machine learning, we have three major concepts. One is the supervised, other is unsupervised, and third is reinforcement. In some books, it is even told as semi-supervised learning, also like supervised, semi-supervised, unsupervised, and reinforcement. So, what is supervised learning? Very simple term. That is how a teacher is teaching the students, like it is like completely hands on. You are sitting in a practical lab and the teacher is teaching you hands on. That is completely hands on. Whatever doubts you have and everything, the teacher is able to guide you each and every step wherever you are stuck. That is called as supervised learning. Then unsupervised learning is the media which I am using. That is, it is via this one. It is used via this YouTube videos or the online lectures. This is the unsupervised learning. That is, though I am able to teach you, but completely I am not in a position. If at all you are stuck, it will be very difficult for me to physically see where exactly the doubts have come. So that is like I can only guide you virtually. Physically, it is not possible. That is why unsupervised. Okay. Sorry, the third one is reinforcement. Reinforcement means once you are performing the supervised, it is a like advanced version of this supervised learning, wherein you are after you are getting the teachings from your teacher, you are doing something better. Better in the sense you are getting a reward. Like the teacher is teaching the complete class, but among them, maybe the 1 or 2% will become excellent. They will become the topper, class topper. And suppose it is like a student is coming out with the same teachings, coming up with a startup idea, like a product or something. So by taking the instruction, the person is coming with something novel idea. That is your reinforcement. Reinforcement. The teacher is enforcing you, the student is getting reinforced. So these are the three major modes of learning in machine learning. And you can tell the sir, then I did not tell you the semi-supervised. It is like semi-supervised in the sense it is a part of supervised learning wherein the guidance is not appropriate. Means you are not when the what is called the teacher is not fully able to commit towards the teaching. So this is a very layman term I have told you. Don't think that this ideas, if at all you are writing in your, if at all you are in a proper coaching and all, don't give this kind of examples. It is just that I am teaching you. Okay, so because there is a proper definitions for everything, you will be getting in the books or in the other blogs and all. So this is just to make you understand what are all these things. Okay. So a type of machine learning where the algorithm is trained on the labeled data. So the first is supervised learning, is a type of machine learning where an algorithm is trained on a labeled data set. This means that each training example is paired with an output label. The goal of supervised learning is to learn a mapping from the inputs to the outputs, enabling the algorithm to make predictions or decisions based on the new unseen data. Okay. So what is this labeled data? What is this unseen data, predictions? We will see to it. So key components are your data set, very, very important. So you know that there are like millions of data sets available. Usually I will say most 99, or I won't say 99, rather 90% of the data sets are free. Some of the data sets are paid, and sometimes you need to take some data. You may need to take some data of some persons. In that, you can directly contact the concerned persons and take the data set. Okay, it implies for both like the numerical data set as well as the genomic data set. Okay, remember this, there are various types of data sets available. Majority is like numerical data set, then you have image data set. For that I will be explaining in the on Monday the image data sets. Then also you have genomic data sets. So that that we will see to it when the time comes. So, and there are so many other data sets depending on what exactly the work you are looking. Okay. So a collection of examples where each example is a pair consisting of an input and a corresponding output level. Input features the data that is fed into the algorithm. It can be anything from numerical value to image or text. Okay. Output, the target variable that the algorithm aims to predict. This can be specific category in the classification task or a continuous value in the regression. Now there is a training phase. So during this phase, the algorithm processes the training data, adjusts with its internal parameters to minimize the error in its predictions. Common algorithms used in the supervision include linear regression, logistic, decision, etc., etc. There are many. So all those complete algorithms is not possible. I will be taking some 2 or 3 algorithms for in this class. There are many more actually, many. So actually it takes like 15 to 20 days just for the supervised learning. Okay. Then you have validation and testing. After the training, the algorithm's performance is evaluated using separate data set called validation set and test set. These data sets are not used during the training, ensuring that the model's performance is assessed on the unseen data. Okay. So I will be telling in all this in a very broader manner. Okay. So again, this is a classification and regression. Many are there. Yeah. Okay. Coming here. So steps are, first is collect the data. Then you have pre-process. Pre-process means getting cleaning the data, then doing statistical analysis, finding the missing values and so on. Okay, then you have training the model. This is a very important step. What do you mean by training the model? A very classic example which I usually give to the students is that you all might be undergoing some training in your playground. Say, for example, you are getting trained for that is during the Republic Day or Independence Day parade you might be doing it, you might have done during your school days. So you remember that before Independence or Republic Day, there will be a 1 or 2 months practice. Okay. Then finally, on the Republic Day or Independence Day, you will be performing. So the PT teacher will be guiding you each and every step, how to perform the march past, and if there is any person with the band, they will be playing the music and so on. So the teachers will be guiding. That is called as the training. The teacher is training you. You can take several other examples like you, if at all you are going to for singing classes or dance classes or any games like cricket or football, initially there will be a training. So training period will be long. As I told that during the parade and all, there will be at least like 2 months or 3 months training, depending on what the teacher, the PT teacher expects. And finally, the testing will be like 1 day or 2 day. Usually it is the final day, that is the on the Republic Day or Independence Day, you will be performing live in front of the audience. The teacher will not be seen in the picture. Okay, so that is called as testing phase. So are you able to perform what the teacher has taught you? That is called as testing phase. So that is good. So you can remember that training period is longer, but the testing period is small. Even in our classification machine learning, in the training state, usually we give the, if at all we are having a data set, the 70% or the 80% data are used for the training, and either 20 or 30% data are used for the testing. Now, as I told you, it's 70% or 80% is for the training. It is not always same. Okay. Sometimes you can change the parameters on your own. Okay, depending on how you want to proceed further. Like you want to give more data, it is the same data set. You need to split the data into two types, that is test and the train. Usually for, and it is 100% that you need to give more data for the training. It is 70% usually or 80%. Okay. If you tell that, sir, why not 60% or 50%? I will say that you should not give 50%. 60% is okay, but your model will not be trained properly. Okay, so it is usually 70 or 80%. Very example that, as I told that during the this one March past, you are getting at least 2 months training. Suppose if I tell that no, you can just get trained for 1 week and perform the Republic Day parade, nobody does it. It is not common. Nobody gives the training for 1 week. It is usually a training for before 1 or 2 months. So usually that is why using the more data, you have to give much more data. That is usually 70 or 80% data, and the remaining 20% or 30% is used for the testing. And finally, the final is that is model validation. So it is very simple model verification, that is your examination. So finally, on the Independence Day or in the Republic Day, how best you are able to perform. Okay, or during the examination, whenever you are writing the examination on the final day, how much marks you are getting? Are you getting 100% marks or 90% marks or 80% marks, etc., etc.? That is called as the valuation. Model is evaluated. You are preparing a model using the training data. You are validating using the test data and seeing how good was the model or what is the performance of the model. Am I clear to all? Am I clear to all? The same is given in the picture. You can see first is the data pre-processing, that is cleaning, transformation, data reduction, etc. Then splitting the data, that is the training set and test set. There may be a validation set, and then you have employ the machine learning model, whatever it is, like SMV, KNN, then you have SBM, Naive Bayes, etc. Many are there. And then you have to go for the model evaluation. Then you have to go ahead with the predictive model, and if any, and then you have to go ahead with the labels. So is it clear to all? Any doubts so far? Is there any doubts from any person? Okay, if there is no doubts, I will continue. Okay. So some example is given, that is a spam email detection. Okay. Email presented by the features such as presence of certain keywords, length of the emails, etc., etc. So, okay, anyway, when we will be performing, we will be taking some biological data. It is just for your understanding. So once the label indicates whether the email is spam or not spam, that is, example, in a Gmail, you are getting some there. There are some in the input. The inbox, you are getting some mails, and you are getting the spam mails. The Gmail is programmed to detect the spam mails. Okay, it has its own programs. Even we also can do that. We can program any of, if at all we are making any particular email client, we can make it like you can classify that which are the emails spam, or which are all the emails genuine, and so on. Sometimes you can see that sometimes some important mails go to the spam. It is like if the email is detected in that manner, even the good mail is also goes to the spam. It happens because it is based on the features. Okay. So applications are, you have several applications in healthcare, like disease diagnosis, medical image analysis. Now there are so many, even for the disease diagnosis, you are using machine learning, that is the supervised learning, and you can check it out that a person is suffering, a person is diagnosed with a disease or not, based on the several data sets you can get from the clinical or research laboratories, or using the MRI data, etc., etc. So there are a hell lot of applications for our own biology and finance. Mainly, that is, these are the three areas: healthcare, finance, and marketing. Means the widely data science is used in these areas mainly. Healthcare, that is our own biology. Anything in the area of biology, it is used. Finance and marketing. Marketing also it is used. Anyway, we will not deal with the marketing as aspect, but it is good to know that yes, it is also used there. Okay, so this is one of the majorly used algorithm, random forest. Don't think that because during the practical we will not be using random forest. We will use something else so that you can also get an idea that what are the other classifiers. Okay, so random forest is an ensemble learning method used for the classification, regression, and the other tasks in the supervised learning. It constructs multiple decision trees during the training and output the model of the classification for mean prediction, that is regression of the individual trees. This approach improves the predictive accuracy and control overfitting. So that is how the random forest works. The simple manner. First is your data preparation. Prepare the data set with the labeled data, features, and the corresponding levels. First is anywhere you have to retrieve the data, or you have to fit the data. That is the first. Then it is data preparation. So you should understand that step is always there. Data input, from where it is like you are taking the data from any database, or you are creating your own data. That is up to you. Then it is actually this whatever is given in the number one is actually the number two. That is data preparation, means how you are preparing the data. What are your how you are classifying it, means that is splitting it. Then creating the bootstrap data set, that is generating multiple subset of the original data using the bootstrapping. Each subset is created by the randomly selected samples with the replacement. Then you are going ahead with the training the decision tree, because random forest it goes ahead with the training. It goes ahead with the decision trees. Train a decision tree on each bootstrapping dataset. During the construction of each tree, only a random subset of the feature is considered for splitting at each node. So what is the decision tree? It is normally like our biological tree, wherein you have like stage 1, stage 2, and so on. You can see in the diagram that this is the level, this is second level, and this is the third level in the decision tree. So how you can label it? That is your model. The model will actually label the particular data as level 1, level 2, and level 3. And how many decision trees will be taken? Everything your particular model will do it. How the model what model you can put. Okay. Like then the next is like making prediction, that is classifying for a new input sample. This is first thing, as I told, is the testing. So you are testing the particular model with the data set. Then you are giving a new input and see that where each particular data are falling. So for a new input, each decision tree in the forest makes a prediction. The final output is the mode of this prediction. Then there will be a regression model. For each new input sample, each decision tree makes a prediction. The final output is the average of these predictions. Okay, so advantages of this random forest, that is improved accuracy by combining the prediction of the multiple trees. Random forest typically achieves higher accuracy than a single decision tree. Robustness to the outfitting. Random forest reduces the risk of overfitting by averaging the multiple trees, each trained on the different parts of the data using different features. And finally, the feature importance. Random forest can provide insights into the importance of the different features in predicting the target variable. And disadvantages, like in the random forest, it is a complex model, means there will be more than one tree. You can see in the previous slide, they can see there are tree 1, tree 2, and tree 3. So that is becomes a bit complex. And interpretability, so you need to interpret accordingly. The individual decision trees are easy to interpret, the ensemble of many trees in random forest can be difficult to understand. Okay, workflow. First is, as I told, input the data set with the features, and you need to give several like attributes and all. Then output, predict the new samples. Then visualization, include the diagrams or flowcharts which can help illustrate how the random forest work. Then application side, like email spam detection, image recognitions, and medical diagnostic. It has many applications actually. Then for regression, you have like in the prediction of the stock prices, estimating properties, etc., forecasting weather. So random forest is one of the widely used classifier for supervised learning actually. Then you have KNN, K nearest neighbor. Don't confuse with the NN. There is NN usually stands for the neural network. This is nearest neighbor. NN, that is neural networks, is a part of deep learning. Do not get confused with that, because it also follows the same abbreviation as NN. There are several types of neural neighbor. This nearest neighbor, one of the simplest is this one. K nearest neighbor is one of the simple instant-based learning algorithm used for the classification and regression tasks in the supervised learning. It operates on the principle that similar instances are near each other, meaning that the algorithm predicts the level of new instance based on the labels of its nearest neighbor in the feature space. Key concepts like instant based, unlike other algorithms that build a model based on the training data. NN is instance based. It makes predictions by directly reinforcing the training instance. And this is a very important part, distance. Nearest neighbor, as you can understand by the term that what is the nearest value. So as I, in a very common example, I can give that if at all you are going in a village, the usual in a village, almost everybody knows each other, and what, like, you can give a proper classification in a village, like say for example any particular group of working community in a village will be staying together, like people who are making the pots, earthen pots and all, they will be usually clustered in the same area. People who are like farming, usually all will be, but who are all a specific type, they will be staying together. That is the actual example of this distance. So which is the nearest is, you can tell that it can have a same function or same feature. So there are many, there are three types of this distance matrix. Usually, mainly followed is the Euclidean distance, Manhattan, and the Minkowski distance. So in the Euclidean, the straight line distance between the 2 points in the Euclidean space, Manhattan, the sum of the absolute distance between the coordinates of the 2 points, and Minkowski, the generalization of the Euclidean and Manhattan distance. And one more thing, if you think that that how to calculate the distances in the KNN and all, usually it is not needed, because you have specific direct function for this three distances. Euclidean, you have a specific function. Manhattan, you have specific function, and Minkowski. Just you to note the theory. That is one important advantage in data science, that you have a proper command or function for in both R and Python. We have specific command. Only thing, it is always better that you can know the theory behind all these statistics. Okay, so just the basic theory, knowledge of the basic theory is I won't say it is more than enough, but just for knowing purpose, the basic theory is enough. Okay, usually that you need to understand the proper statistics, as I told in the last class, to handle the data science. But if you just understand the basic concept, it is far better. You can handle the things. Okay, but while creating the packages and all, you need to understand the statistics actually. So if you are really interested in creating a new package and all, it is important that you know the statistics. But if at all you are utilizing any particular packages and all, then it is not needed. Okay, so number of neighbors, the parameters KKK determines the number of nearest neighbors to consider when making a prediction. The choice of KKK can significantly affect the performance of the algorithm. So small KKK can lead to the noisy model. Large KKK lead to a biased model with high bias. So what is noise? Noise means there will be lots of repeated data. That is why it is called as high variance. And biased means the bias means, you can lay simple, the meaning is that you can feel that all the values are the same or similar. That is one very example, classic example of bias. So how the KNN works? So you need to collect and pre-process the data. That is the first step is same for all, actually all the machine learning. First two steps, this is data preparation is the second step. First step is the retrieval of the data, and second is the data preparation. It is same for all. Then you have to choose the actual, that is the K, that is the distance. Decide on the number of nearest neighbors to consider for the next predictions. Then you need to calculate the distance. So what distance you want to put, you need to identify which is the neighbor who is nearest. So very simple meaning, for the neighbor who is nearest is the person who is immediately next in your next house, your closest neighbor. That is called as nearest neighbor. who is like just you can call person, hello, how are you, from one window to other window. That is your very classic example of your nearest neighbor. Who is the nearest? Okay, the next house. Making prediction, that is the classification, assign the class level that is most frequent among the KKK nearest neighbors, and regression to compute the average of the target values of the KKK nearest neighbors to make predictions. Advantages, actually KNN is very simple. KNN is one of the most simple rather than the random forest or the decision tree classifiers. So no much training is required actually. Since the KNN is instant-based learning, there is no explicit training phase, and it can be used for both classification and regression. Disadvantages, competition intensive. KNN can be slow during the prediction, especially with the very large data sets, and it requires calculating the distance to all the training instances. Memory uses KNN stores all the training data, which can lead to the high memory usage. And sensitivity to the irrelevant features, KNN can be significantly affected by the presence of the irrelevant or the redundant features which can distort the distance calculations. Okay, so applications. So classification tasks, image recognitions, handwriting detections, recommendation systems, etc. Regression tasks, prediction the house price, estimating temperatures, forecasting sales. An example data set with the features like attributes of houses, labels, and prediction of the new samples, that is predicting the category of a new image, new price of the house, etc. etc. Okay. So there is a given of iris. Anyway, we'll do this. Okay, fine. Okay. Now everybody, please open your Google Colab. Please open the Google Colab, everybody. Okay. So all have opened the Google Colab. Explain the KNN in handwriting detection, like how it works, as it is one of the applications. Okay. That is a part of image recognitions. Actually, it comes. It is a part of linguistics. In linguistics, you need to read. You need to provide the how the handwriting features are working, and based on that, you can identify the other handwriting. It is a part in linguistics. Actually, you need to use. Like many algorithms like OpenCV also it comes then and from where you are taking the handwriting, is it from a image source or is it from the PDF? It depends. And again handwriting again that if it is English handwriting, so the uses of the libraries will be different. Usually, you can directly read from a PDF when it comes to the English handwritings. But when if it is in other language, that is Hindi or Bengali or Kannada or any other language or Tamil, so in that you need to use some other packages. Usually, first you can detect the language, and you can use there is something called as the Indic NLP, INLTK. INTIC INTK package. So you can utilize the INTIC INTK package and you can perform it. So this is among so in India, many people are using this INTIC NLTK, that is INLTK package. It was created by, I forgot the name. He's a Tamil guy. He has created it for and it supports maximum of the Indian languages, whether it is like first you anyway need to convert the handwritten into the normal letters or numbers, and then you can go ahead with the NLTK or INLTK. NLTK usually for the English language. INLTK is any Indian language apart from English. So that's why I told in linguistic it is very nicely used. Okay. Okay, fine. So first we will build a classification Python. I have actually written many steps. What I will do is at the end of the class, I will try to share this notebook with you so that you can understand this. So that is the steps for this. The what classifier we are building in Python. So first thing is that in general in the machine learning, for any machine learning task, first thing is you need to import this SCI kit learn. That is scientific kit learn usually, and it is used for most of the machine learning activities. So you need to import it. This would be the very first step for building a classifier in the Python. First step, we need to install the Python package called SCI learn, which is the best machine learning module in the Python. And this command will help us to import. Since I am using Google Colab, I have not given this command. But if at all you are using like PyCharm or Visual Code Studio or even in the command line, you have to give this. So the advantage of Google Colab is most of the packages are inbuilt. Okay, this is actually a command. Don't think that I have put it in the text. It doesn't mean that you need not run. But if at all you are not using Google Colab, you need to run this. Okay, there are many packages which is inbuilt in Colab. That is one advantages of Colab. So there are many packages inbuilt, so you need not to install this sklearn here. First, actually, if at all you need to do in other platform like PyCharm or even Notebook and or command line, first you need to give the command as pip install sklearn. That is the first command. Then you have to go ahead with the others. And even this command is wrong. I should be small and sklearn S should be small. Remember this. So don't think that the code which I am giving you, it actually work all the platform, but some of this like this one, you have to install it in for the other packages, sorry, other platforms. So you import the sklearn's data set in this step. We can begin the working with the data set for our machine learning model. Here we are going to use the breast cancer Wisconsin diagnostic database. So I am already using the inbuilt data set. Okay, inbuilt data set I am importing from the sklearn package. And if at all you need to download and you can install it, that also you can do it. That is possible. Either ways you can do it. So you can just in the Google, in the GitHub or in the Kaggle, you can find this breast cancer data set, and you can you can save it in your directory and you can utilize it. So don't think that the data set you can directly take using the command line, using this method. So there are two ways how you can take the the data set. Either directly you can load in this manner, or you can use even the link to download it and you can upload it. So in Colab, this is one of the advantages that it will everything is in cloud. So many advantages will be there in the cloud for all these things. Okay. So this is your first command. If at all you are using Google Colab, if you are not using Google Colab, you have to use this particular command. Okay, I'm just putting in the chat box. Please use this because today it will take time. So already I have prepared the notebook for you so that I don't waste time for typing it. Okay, so then now the following command will load the data set in the notebook. That is data load breast cancer data. So this will be importing it and it will be this command will be making it available in this particular notebook. Okay. So in this particular breast cancer, there will be lots of labels. You will be seeing it. So classification label names, the actual target, that attribute features that are using the feature name. So classification of the label names you can use by the target names, which I am not given here. Then the actual, that is actual labels are the target, that is the feature names. So here you have this label name, that is your target names, and these are the feature names. The attribute data with the help of the following command, we can create new variables for each important set of information and assign the data. In other words, we can organize the data with the following command. So what are the labels here? That is malignant and begin. So you can print the this one labels. So which it is already present in the breast cancer data set. So the above command will print the class names which are malignant and begin. So now the command will show that they are mapped into the binary value, that is zeros and ones. So this one you remember it. 0 represent the malignant cancer and 1 represent the begin cancer. Okay, this one, because as I think in the last classes I told that if at all you cannot the if the data are in the text manner, that is a string, and you need to utilize the data, you need to convert it into like 0 or 1, you need to give any number. So because you need to utilize this malignant cancer and begin cancer. So you are giving the label. Okay. Now you can print the label, that is print labels, and it will take it. Okay. The two commands below will produce the features name and the feature values. So for you can print the feature names. Okay. Then you can find it out how many are with 0, features 0. So for a malignant, I have given as 0. So print feature 0, these are all malignant cancer. Remember it. Here 0 represent malignant cancer. I have given here that 0. So these are all malignant cancer. So from the above output, we can see that first data instant is a malignant tumor with the radius which is 1.7990 e to the power of plus 1. Okay. Next, as I told that you need to split the data set into test and train. So for that, you need to import the test train speed from the sklearn. So organize the data into the sets. In this step, we divide our data into two parts, namely training set and the test set. Splitting the data into this step is very important because we have to test our model on the unseen data. To split the data into the sets, sklearn has a function called test and split. With the help, we can split the data. So please import this sklearn model, this test train split. This is a very common and important command in this one, machine learning. The command will import the test plane split function from the sklearn. The command below will split the data into the training and test data. In the example below, we are using 40% of the data for testing and the remaining data will be used for the training. So 40% data is for the testing and remaining means 60% is used for the training. As I told you, it should be always more. And you can tell that, sir, why it is like 40% we can give, we can give more also, less also. Here you have to give less because you cannot give it more than 40 for the test. You can see here the test train split, train levels, test levels, then feature labels, test size is 0.40. So test data is 40% of the data. If you want to use it for the 30% data, to give there as 0.330. And if you have to give as 20%, you have to give as 0.2. Remember that. So other codes will remain the same except for test size. Okay. This is common. Here you can change it, and random state you can change it. Okay. It depends on what values you are doing. Now, what is the random state? So random state 42, we get some train and test data across the different executions. But in the time, test and train sets are different from the previous case with the random state 0. What is a random test state means like at what stage is your data set? Okay, if it is state 0 means it is completely in the normal state, and if it is like if you are increasing it to 42 and also the data will be completely mixed up and it will be getting splitted. Okay, so it is and this random state is very much used or more common in your neural networks, not much in machine learning. Okay, in the neural networks anyway, you have to give it starting with you have to give it 2 or 3 times this particular command. It should start from 0 and it should go on increasing. So how much time you need to go into the particular data set. Okay. So here I am using the naive Bayes classifier here. Okay, building the model. We need to build the model. We are going to first time I'm using the naive Bayes classifier. Okay, for that, for naive Bayes, I am importing the Gaussian naive Bayes. Okay, so you are importing the Gaussian NB in your notebook or in your working place, and then you are going to fit. This is the fit command. We will train the model by fitting. So gnb.fit. So GNB is coming from here. GNB Gaussian. So you are giving it, you are defining Gaussian as GNB, and GNB fit will fit the in your training, you can see this is the train. So training data, the Gaussian will fit. Okay. So for whenever you are giving this Gaussian, this command will remain the same for all, and this fit command will also remain the same. There will not be any difference. If you are changing it, you will get an error. Okay. These are all like standard commands. Now you are giving the predictions. So evaluate the model and its accuracy. In this step, we are going to evaluate the model by making prediction on our test data. Then we will also find the accuracy. For making prediction, we use the predict function. So here you are giving predict GNB, predict test. Here you are giving train. So based on the train, how good is the test? Okay. So above series are zeros and ones. So you know in the very beginning, the zero is for the malignant and one is for the begin. So you are getting everything as zeros and ones. Now you need to understand the accuracy. So from sklearn, you are importing the accuracy score and you are fitting it. You can see it is fit on the predicts. So you will be getting the how good is your model in the data set. So it is like 0.95 means it is 95%. You will be getting the accuracy as always as 0 point something. So don't think that you need to give like 0.95 and so on. You have to write it like this is 95% accurate, no 99% accurate, or if you are getting as 0.60 and all, you need to write it as it is 60% accurate and all. Okay. So here it is like 95.17, or like if you are writing any your thesis, then you can even give like this approximate 95% accurate. So you have already built a classifier. So I hope everybody has got the results till this part. Okay. So next we are using the naive Bayes classifier. So naive Bayes is a classification technique used to build the classifier using the Bayes theorem. The assumption is that the predictions are independent. In simple words, it assumes that the presence of the particular feature in the class is unrelated to the presence of any other feature. For building the naive-Bayes classifier, we need to use the Python library. Again, it is the sklearn. Sklearn keys is very much used, and these are all you will be finding in a very good book actually. What is that book? I will say you. This is a very good book actually. Hands on. Yes, this one. This is a very good book. Yes. So this is a very good book for this sklearn. Okay. And when it is TensorFlow, it is the neural networks, and sklearn is for the machine learning. A very good book. The PDF is available. Even I also might have got this PDF in my mail. I had to check it out. One moment. I will. there. Okay, you can download it. I have shared in the chat box. So this is a very good book. There is one more book by an Indian author. What is it? Anyway, I will later. I will see what is that. Okay, it's a very good book. This one. Okay, fine. Let us come here. Okay. So there are three types of naive Bayes, that is Gaussian, Multinomial, and Bernoulli under the sklearn package. So to build an naive Bayes machine learning classifier, we need the following. Again, the database we are going to use the breast cancer. This database data set includes various information about the breast cancer tumors and all. So it has like 569 instances. So you can see about the data sets. Okay. So this complete command I am giving here. Okay. So here you can see what is happening. So from sklearn, you are importing the breast cancer. Now you need to load it in your this one in your working space. So you are giving this the variable name as the data. Okay. So the data can be organized as follows. Like the label names it is given, labels and feature names. The same thing like the last. And if you want to see the data set, you cannot see it completely. You can use the command head. Usually, it is the head command is used, and you can view the first five lines. So usually that is used. Okay. So here also you are getting the same, like the label names you are have malignant and begin. Okay, and you are marking it as 0 and 1. Okay, so this command is again the same, that is print label names. Okay, so you are printing it, making it as zeros and ones. Okay. So here also you can see the first data instance is 1.799 e plus 1. That is the first one you are getting. Again, it is the same command here. From sklearn, a model selection, import the test train split. Here also you are using the 40% data. And random state you are putting as 42. And then you are importing this Gaussian from the naive Bayes, and you are fitting in the model. Okay. So again, you are importing the accuracy. And here you can say that your accuracy is 95% accurate. Okay. Now we will move to the support vector machine. So this classifiers is like, this is a general one, and above all, like I am already using the classifiers are already available. I'm just importing it. So that's why I told in machine learning, you need not worry. Most of the algorithms and the classifiers are like inbuilt, and you can import and just you have to utilize in your data set. The main thing is what data set you are taking and what is the accuracy you are getting. Okay. So in machine learning, that is the main thing. So you need not worry much. All the classifiers are available, so there is nothing much, and you can, like, you have to understand and statistics. Okay, and on that, even publish your research papers. Okay. So next we are moving to the support vector machine. So basically, support vector machine is a supervised machine learning algorithm that can be used for both regression and classification. The main concept of SVM is to plot each data item as a point in the n dimension space, with the value of each feature being the value of the particular coordinate. So n would be the feature we have. This is a simple graphical representation. Okay, to understand the SVM, in the above diagram we have two features. You can see there are already two features. We first need to plot these two variables in the two dimension space, where each point has two coordinates called the support vectors. The line split the data into two classified groups. The line would be called as a classifier. You can see that these are the classifier. Here we are going to build the SVM classifier. We used last time the naive Bayes. Here we are using the SVM. And we are taking the iris dataset. Last time we took the breast cancer dataset. This time we are using the iris dataset. Okay. So let us start. Here we are. See, first commands are, you are using the pandas, numpy, again sklearn and matplotlib. Okay. It may take some time. Pandas is for, and numpy are mainly for the numerical calculations. Sklearn is for the machine learning, and matplotlib is for the plotting. So this is very important. Import pandas as PD. So PD, because you will be you're using these PDs in the subsequent lines. NumPy you are importing as NP, so NP you will be using for the calculations. From sklearn you are importing SVM and the dataset. So dataset you will be importing in the next phase, and matplotlib, pyplot as PLT. So this and all your using. So PDR is your command. PD, NP, SVM, PLT are your commands. Remember it. So then you are using the iris dataset load. So datasets you are giving here, datasets. So do not make it like mistake that making a dataset. So datasets you are importing. So iris datasets load iris. Okay. Now you are seeing that there are two features here. Okay. So you are getting the two features, and you are splitting the two features for X and Y. Then you can plot it. Here you will not get the plot, but you are giving the commands for plotting. You are splitting it mainly. You are creating a mesh for the plotting. So you are giving what all the features you need for the plotting. Then you are creating the grid actually here. Okay, so first you are giving the two features in the iris data. Y consists of you can see that is the second feature, that is for the y axis. You are giving specifically, you are giving two in the sorry, it is the x data. For the Y data, you are giving the target data. So X max and X min is the your plotting lines you are giving. So minimum is from any line, that is X colon is anything, and it is 0. That is for the X min, and maximum it is the again, that is again anything, and max plus 1 it is coming. Again Y min and Y max. So that is again in Y min you are giving the X minimum value, and there you are giving the maximum value for that is for the Y. Sorry, for the X value you are giving in the Y. Then you are creating the grid using the NP. Here you can see that this is NP is used here. NP is coming from the NumPy. Okay, remember it. So from the NumPy you are giving this NP mesh grid. This is the command for in the this one NumPy. NumPy you are giving this command. So NP arrange X mean and Y mean, and H you are giving it here X max and X max and X mean. So again you have NP arrange. NP again it is coming from the NumPy. So you are arranging the X max, X mean and Y max. Sorry, Y mean and Y max here. Then you are plotting it. Okay. Then you are giving the creating the X SVM classifier. Already you have imported the SVM here. From sklearn import SVM. So so here it is SVM. So you are defining SVC classifier. It is defining SVC classifier. It is SVM. So SVM is coming from your here. So sklearn import SMV. That is the SMV you are getting. So from SMV, SVC, kernel. Kernel is your linear, and the C is your the points actually, and your decision function is OVR, that is the oval shape, and fitting, that is X and Y. X you are giving here and Y is here. Okay. So this one it is coming till here. Okay, I will copy from here for you. Then you have Z SVC classifier. SVC classifier you are defining it here. So Z SVC classifier predict X plot, and Z reshape XH dot shape. Everybody is getting so far. Then you are giving as PLT. PLT you have defined it here. So here PLT is there. So PLT figure size is 15,5. 15 is the x-axis value, or the I will say that is the length, and 5 is the breadth. So this is your figure size. You can alter it. Always, as I told, you can alter this part. You can change the figure size according to your choice. Okay. Subplot, if you want, you can do it. PLT subplot. So PLT subplot is an what I will say, it is an you can also give it, you cannot give it, that is up to you. If you need a subplot there, then this is important. Plot contour. Plot control, you have xs. Xx is defined here. Here you have xx and y defined here. So xx, yi, z is defined here. Okay. Then you are defining the CMAP as PLTCM, giving the tab as 10 and alpha as 0.3. Then you are plotting PLT scatter, means it is a scatter plot, and you are giving the values x. X is defined on the top. Again, x is defined in the top. C equal to y. C it is defined. Where is C defined? You can yeah, C is defined here. C equal to y. So y is anyway defined here. So you are defining the C with C map. Plot is CM set 1. Okay. Then you are giving the PLT X level. X level is labeling of the X axis. So X level you are giving as sepal length. PLT X level is means that you are labeling the X axis with sepal length. You can give it in the quotation it is mentioned as sepal length. If at all you are using like giving some other data set apart from iris, you can give some other name as per this. This is like you can change it accordingly. And PLT Y level is again you are labeling the Y axis. Okay, sepal width. You're labeling the Y axis. Then plot xlim is you're defining the X axis. Xlim command is for defining the X axis. Plot there is one more command like ylim. I am not using it here. Ylim is for defining the Y axis. Okay, and this is the plot title. So PLT title SVC with the linear kernel. So once you are giving all the kernels, you can see that SVC with the linear kernel. It is the plot title. You have given it here. So here you have sepal width. Sepal width is coming here. Sepal length is here. You can see there is 3 classifiers. You have 3 different colors of plot. Red color, you have gray color, and you have orange color. So you're getting a 3 separate classifier. And plot size is mentioned there. Here it is like text size is 0.5 to 1 with SVC kernel. Okay. So this is the classifier from the data set which is given for the iris data set. Okay. So how you can understand it for each and every data set, you can see that how it is coming. So you can see that maximum of the classifier, this particular classifier contains the maximum of the points. Okay, so hopefully you have got the graph, so you can see it, and then since in the if at all you are publishing anyway, this particular work you cannot publish in bit, but if at all you are taking a different data set and you can utilize the same pipeline, that will be you can publish it. So any doubts you have, I will be sharing uh, this particular notebook to you. Okay, I am sharing it in the chat box. Okay. So you will not be able to edit it, but you can definitely take it. It will not. It may not run in your system, but you can take the commands here. Any doubts? Apurva, any doubts?
So for each and every statistical model, we have to choose first. We have to install first, right?
Yes, you have to install. Yes.
For
Since
each
it is
and
the
every for each,
Google Colab, I am not installing it. I have
okay,
already given that command here. Since Google
okay,
Colab, it is not necessary to install anything. That is the advantage.
okay. For
Yeah.
R and all, we have to install only, na? For R, we
R
have to
R
install the
you
library.
need to install, but even in Google Colab, you can use R. See
Yeah,
here, it is both R and Python is there. So Google
okay,
Colab you can use for both Python and R.
okay, sir.
Yeah. So this is the advantage of Google Colab.
Okay, sir.
Yes, this book is also very good. Can you see this screen?
Yes, sir.
Yeah, this book is also very good. You may not get the PDF for this book, but this book is also very good. This is for both machine learning and deep learning. Even the book which I already shared with you, that is also a very good book for this, both this machine learning and deep learning.
Yes, sir.
Yeah. Any further doubts you want to ask?
No, sir.
Okay. So I have already shared you this notebook. If you have any doubts, you can let me know, and we can meet on again Monday, same time. I will be discussing the image processing. Okay?
Sure. Sure.
Okay.
Thank you.
Okay, then thank you. Good night.
Thank you.
Thank you, sir.
Thank you.